wanna identify the parts of this new idea, which is just another idea in our function world, where the x is in the exponent. Okay, for the quadratic function, the cubic function, they had exponents, but they were constant numbers. Quadratic, the exponent was 2. Cubic, the exponent was 3. For an exponential function, x is the exponent. So they break it apart. There's an exponential function that grows and an exponential function that decays. So in applying it, we want money to grow. That'll be one of our lessons. And another application is we want like germs to decay. So that's why there's two different kinds, and I'll point out which one's a growth and which one's a function. Who makes the growth, who makes a decay, it'll show up. Okay, so you guys know A, B, H, and K. You know how they transform functions. The things we don't know is what math do we have to do to show the transformation and therefore choose the graph. And 100% of us in this building don't remember the math we have to do because it's not a readily accessible idea until you start thinking about how it changes. They'll figure it out, you know, but they don't have like not like the Pythagorean theorem or, you know, the distance formula. They don't have that memorized like that, like the most of us. Okay. So exponential growth functions is a game. And what makes it growth is the fact that this base number here is larger than 1. So if I take a number to a power, like a 5 to the second, third, and fourth power, it's going to grow as you move along the graph reading a book. So get your numbers in the game, friends. We don't need our iPads. It's all on paper with our pencil in colors, okay? And I'm going to give you what you need. We got done this morning, fourth period, with the notes. So that's tomorrow's work day on this. But this, understanding this will get you what you need, the tools you need to complete the assignment. So right now we have to think about this picture. If you remember, there's a parent function that goes with every story. Right here is the parent function. Okay, that's what happens. This is what an exponential function looks like. It looks like a rocket ship taking off if nothing has changed about it. Its orange horizontal asymptote starts with the x-axis. That line will never cross the x-axis because no matter how small of a negative exponent I put in there, I'm just getting a very small fraction. Remember, negative exponents take the reciprocal, and so if I took this number to a negative power, it just flips it over and makes it smaller, smaller, smaller. But there is no number I can put in here that will go negative result. Okay? If b is greater than 1. Okay? There's no number I can put in there. The base is greater than 1 to make this curve go below the x-axis. So if you go changing up things, your asymptote, remember that's the no-no line, turns into whatever is being added outside the function here. So if things are changed, you find the change written right here in the equation, and it creates the horizontal asymptote on the graph. That's no different than, it's a vertical, or it's a shift up or down because it's a y number. This makes things move up or down, remember? Out here. I don't know if you remember that or not. Am I close enough, or do you want me to zoom in? Anybody need a zoom in? Are you happy looking at your paper and connecting it to what I have? Because I'll eventually have to zoom out for later, but I want to make sure you could see it. Okay, here's where people forget. Usually, if you want to graph an exponential function, you just plug and chug, and you get some pretty ugly numbers. And you could use Desmos and then, shortcut everything. But obviously, you won't. If you in an assessment for college and career readiness, you won't have access to that. So you won't be able to put in the equation and get out the graph. You're going to have to know how that graph was created. Okay, so we're doing some handwork here. It's just like sewing your own clothes or baking your own cookies. You don't have to. Somebody be glad to sell you some cookies. Somebody be more than glad to sell you the clothes. But here we're creating our own graph, so then when we have a chance to pick a graph, we know which one is right. Okay? Now we're going to pick green for this transformation, H. And that moves things left and right. So it starts at 0 here. That's this one. And then it moves it over. So it shows up as the X value in a point that's been moved over. Now I'm not going to color it green because it's just not the H that moves it. Whatever is being subtracted up here in the exponent will make that move from the original 0 to H. And this is the part people forget, and I would understand why pink. Okay, I'm going to make the A pink. The A is a multiplier outside, so then that A will change the move, up and down. So you got to add those two numbers together in order to find a point that you can find on the graph and say, ooh, this is the graph. But 1 point is enough. They have 2 points because they want you to be able to draw that dynamic of the curve. Here, this is just a nice, normal upshot. Here, if A is bigger than 1 out here, then it goes whoop, up high faster. Or if A is smaller than 1, then woo, it takes longer to get out. All right, so in the original graph is the B number, and B's got to be bigger than 0. And it crosses, if I go 1 over, this is B up, okay? And so what do I do to the B to show the transformation? I have to multiply it by A. The B stays B. But in order to find this reference point for transformation, I have to multiply it by A, which was pink. After I multiply, I added to K, which was orange. Then my X value for the reference point, they're just adding 1 to your X move, or your H. Okay. Remember, H is still crazy with X up there. Up here, it says X minus H. I'm going to zoom in for that one so you could see. And you guys have it there, but I want to show it on the video. Remember that story? In all our functions, the relationship between X and H was the subtraction relationship in the template. And so it's going to be, I got to pull out the H as the number being subtracted from X. So if this said plus 3, my h is a negative 3. Why is that a big deal? Because I have to use it in my reference points to transform this curve. So what am I going to do for your assessment? I'm going to give you the equation. You have to find the graph, okay? That's what you're going to do on the homework. And then I'll assess you on that. That's this lesson. There's only one more conversation we have to talk about, and then we can practice with the examples down below. We have to talk about the domain and range. So the domain is the same for all exponential growth functions, yay, yay, without any, like context. So if they don't tell us anything about the x values, all x values count, okay? So if we want to write the domain, we write all real numbers right here. I'm just using yellow because we don't have another color for that. But the range does come from K. That's where this number comes from. The range, because it's a growth function, friends, it's a greater than sign. Notice there's no equal to's in this story. Notice, notice, notice. How did I know this was a -1? Why start after a -1? Asymptotes can't be included. Why isn't, I'll show you the picture clear up here for this example. Why can't it be a -1? Because this guy can never be 0. I can't put a number in that x up here. I can't put a number in there to make that 0. I can't take a number to a power and get 0. There is no such thing. Nothing. Nothing. There's no exponent that will make the base of 2 0. So that's why you start after a -1. So that's where they get this -1 from out here. How did I know? Remember up here? Right there? Remember? Okay, is that one thing that's being added? Either it's in front or behind, They could have it up front over here as long as it's being added to the term that has x for the exponent. Okay, so we got K here. Oh, this is what K is. Right, over here they're just listing the asymptote. Okay. That's K. K's got a big part of the story in this lesson. It creates the asymptote, and it also tells us the range. And I don't know if you remember that from previous functions, things like that happen. Maybe it was the rational functions where things like this show up. So in the mathness, you guys, you'll use these and you'll remember them for a moment. Then after that, you'll have to go back and refresh your memory, and that's okay. That's okay. It's okay. Can't remember everything. You guys are responsible for a lot of information, and we are in a generation. It's not if you know it. It's if you know where to find it. Okay. So any commentary on K? I talked about him first because he was the big muchacho in the story. Okay, now we're going to do the A thing. That's pink. He just shows up here. He shows up here in the formula. I'm going to put a 4 wherever I see A in the formula. And then these other things are just arithmetic, right? They took 4 plus a -1 and got their 3. Took 4 times 2 plus -1 and got their 7. That's what they did with A. And you find it If nothing's out here, it's a 1, remember? If you don't see a factor, a multiplier, it's a 1. Okay, blue for B. That's this big bad boy right here. It's the base of the number. I'll just put it here. Where does it show up in our story? It's a multiplier so that our curve will go either, what rate the curve grows. So it's going by the exponent of 2. So that's the only 2 places you use the B. This first one, the B was 1. That's why they don't have it there. But this one, B, they use the B value in the graph so you can plot that point. Okay, and then we've got H, green H. It is a positive 3. Notice that. I want to color the whole thing. There we go. He shows up in the first reference point as the X value. So yeah, you don't do any math to that one. You just put it there. And then our second reference point, we're going to add 1 to the X value. And then we get a new X value, which then in turn will generate a different Y value. So there's H's. H's game in an exponential growth function. The reason it's growing is because that number is bigger than 1. If I put 1 in there, the graph's a line because it's 4 times 1 to any power is just 4 times 1. 4 times 1 minus 1 is 3. This graph is y equals 3. That's a line. Y equals 3. That's it. So this has got to be bigger than 1, or as for our next lesson, it'll be smaller than 1. And there's the picture. So you get to do that. We already talked about the domain and range. That's our lesson, guys. We'll do a couple examples and call it hopefully, because we don't remember ABHK, call it an understood idea. Right, let's go to number 1 on this paper. We'll go ahead and state the domain and range. Then on our graph, we will come up with our points and draw our curve, sketch our curve, right? Remember the range of the Y values. I'm just going to use D, and then I'm going to say all reals. I'm lazy. It is in your homework. They're going to have this choice, right? You guys can type that in. You see which directions the lessons go. You see the direction, no equal signs. Remember, you can't capture infinity. So that's what they're going to have you type in for domains in the homework. Every problem's going to have parts. So you're going to have to pick the domain. Then you're going to type in the range, which comes from the Y values. Y has got to be greater than, because it's a growth function, my K. That's where I got it, right? This is my K number. In our homework, it's got always on the right side of our multipliers, but it could be in front too, so don't be ready for anything. Just never know how they're gonna pop them in there. We got those done. What's really, 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 really cool is that A, B, H, and K go in order. So A is 3, B is 4, H is 1, K is 1. See the da-da-da-da-da. A, B, H, K. Musicians among you. You got your graph paper. Put your formulas on that graph paper. keep this out. Graph paper number 1. I'm going to put H, and then I take A plus K. Oops, sorry. I'll plug in what I had here on this paper in here. 1, comma, 3 plus 1 is 4. So I'm going to graph that ordered pair 1, 4. My other one, I add 1 to H, and then I take AB plus K. So it's, they're kind of connected. Okay. So H was 1, 1 plus H is 2. A times B is 12, plus 1 is 13. So I'm going to have to use my imagination on my graph to graph that one. And remember our asymptote. We get this from K, right? Don't forget. We get this from here. I'm going to have to zoom out a little bit so you can see the graph. Get it in here. Okay. So I'm just going to make this orange to emphasize where I got my number 1 from. This is y equals 1. It's dotted line. My k value. So my curve will never cross this line. Now I'll draw my 1 over 4 up dot. 2 over, there's 10, 11, 12, 13 dot. I have to use my very interesting artistic ability to draw that coming from low going up high. This is not a corner, it's supposed to be a curve. Oh. Yeah, there's that. So have some fun with that little game. If I can kind of scoop it up better. There we go. Okay, it does not have to be perfect, friends. This is sketching. I'll show you what they have. Yeah, just like that. This is what theirs look like because they've got a bigger graph than I do. Yay for protective cases. Okay, there we go. Okay, so on the homework, all you'll have to do is, come up with your reference points, and then you can find the graph. Okay, thankfully you will not have to draw the graph. So it will be a temptation to just use Desmos and skip all the thinking, but you can use Desmos to verify your thinking, but don't just jump right to Desmos. If you put this into Desmos, you'll get that picture, but we want to be sure to understand where these parts came from. Okay? So I'm going to jump down to number 3, where the domain is all reals. That's a good one. Because that, that's the x values, and there's not a number I can't put into that exponent. There's no exponents. But the range is from, set of all y's, such that y is greater than -5. It'll never be a -5. Because this has to stay a number. A is the multiplier on the side. B is the big bad base. H is not +5, but a -5, because I have to write the value that is being subtracted from x. And then my k happens to be a -5 as well. So I picked this one because of the, A. If you don't see an A, remember it's a 1. Otherwise, these are just the same as you know, what we did for number 1. They've got A right in your face. H is what you see. You know, easy, easy. Okay, so let's do number 3 and we'll be done. You get to the homework or whatever you have for your last 20 minutes with me. Set. We got all the parts. Okay, we'll get this going. Practice your, this is number 3. Practice your H, your like reference points, A plus K. And this one's H plus 1. Did they say H plus, oh, they said 1 plus H. Does it matter? No. AB plus K. 1 plus H is H plus 1. Looking up here, I'm going to take a negative 5, comma, 1 plus a negative 5, negative 4. Here, I'm going to add 1. That's a negative 4, comma. Then I get to multiply. A times 10, so that's 10, positive 10, plus K, which is a negative 5. That gives me a positive 5. So this guy is moving fast. It has a base of 10, so every power higher multiplies by 10. How's your brain? Math is not difficult, is it? We can add 2 numbers together pretty easily. You just got to know which ones to add, right? Parts is parts. Okay, I'm going to draw my asymptote where y equals negative 5. This is the no-no line. That's orange. It'll clear down here. It'll clear down there. I can put it all in the picture, right? So that will help you on the homework, where to find the asymptote. Looks like the line is above the number there. And I graph my 2 points. Negative 5, negative 4. And negative 4, it goes clear up to the number 5. Yeah, there's that. Negative 4, 5. And then this guy is just like, I'm going to do this first. And then zoom down. That seems to work easier for my backwards, upside down brain. Okay, here we go. Now theirs looks a little different because, well, it doesn't look that much different. I was going to say they have a better scale than I do, but it's a good one. There you go. I'll move that and call it a day. Dig into your homework now. Now you know where A, B, H, and K live. There's no corners here. It's all curves, even though my sketch looks otherwise.